Hello, everyone. My name is Ding Kun. I'm a registered U.S. patent attorney admitted in California and the District of Columbia. Before becoming an attorney, I earned a PhD in electrical engineering and worked as a hardware engineer in Silicon Valley. Over the past year, I have been exploring one question. What does it take to build AI systems that legal professionals can actually trust? Today, I would like to share one possible answer through a case study. Today's legal AI has made tremendous progress. Modern platforms can answer questions, draft documents, review contracts, and automate legal workflows. They are already creating real value for lawyers. But if we take one step further, professional legal work is more than a collection of AI tasks. Legal work always involves structured reasoning, multiple stages of review and revision, collaborations across teams, consistency across work products, and ultimately human oversight. To investigate this challenge, I built a prototype AI-native legal production system to better understand the principles behind trustworthy legal AI. Let's first compare a traditional legal team with an AI-native legal team. On the left is the workflow most of us are familiar with. An attorney works with an AI assistant to send prompts to large language models and draft documents, reviews the results, revises based on feedback, and then repeats the whole process. Notice that attorney is responsible for three distinct responsibilities: producing work products, review their own work, and incorporating feedback. Now, suppose we decompose those responsibilities. Instead of one attorney doing everything, we assign each responsibility to a specialized AI agent, a production agent, a compliance review agent, and a feedback agent. The attorney still reviews the work and provides feedback, but each AI agent now has a single, well-defined responsibility. That raises the next challenge. How do all these agents work together reliably? The answer is orchestration. By orchestration, I mean a deterministic execution pipeline that coordinates every step of the workflow. Rather than allowing each agent to operate independently, we have a pipeline that determines which agent runs next, what inputs it receives, and which work products are produced. The pipeline also tracks versioned work products, validates inputs and outputs, and maintains a traceable execution history. In addition, on top of the pipeline sits a pipeline managing agent responsible for overseeing the entire execution. At this point, the engineering challenge is no longer prompting a single large language model. The challenge is orchestrating reliable execution pipelines that coordinate specialized AI agents, attorney feedback, revisions, and legal work products. Now, I would like to show a proof of concept. To explore these ideas, I built a small AI-native legal production system for patent invention analysis. The system includes three specialized AI agents: a disclosure analyzer, a compliance reviewer, and a feedback reviewer, along with a Python execution pipeline and a pipeline managing agent. So the question is, why using a deterministic Python pipeline instead of letting a large language model controls the workflow? Because large language models are excellent at reasoning, but they should not be responsible for workflow execution. Workflow execution requires deterministic behavior, validation, version control, error handling, and reproducibility. Those responsibilities belong to software, not language models. So now let's see how the system works. Okay, let me begin by showing the chat interface. I created a Telegram group that represents a small AI native legal team. The group has four AI agents: pipeline manager, disclosure analyzer, compliance reviewer, and the feedback reviewer. On the left, I have a patent disclosure that we will use for this demo. I adapted a publicly available NVIDIA research publication. The link is provided in the slides. I have also saved this patent disclosure under the folder called Project 001. Now I will ask the pipeline manager to initiate the process. First, I just tag pipeline manager and say hello. Okay, it replied, hey. Tag the pipeline manager again. And I just put, please work on the invention analysis project ID P001. Just follow the text file. Okay, send. Okay, and the manager said, got it, executing the pipeline now. So let's wait a bit. Okay, the pipeline has completed its initial execution. Here's the response from the pipeline manager in the chat box. We also noticed that a new folder called claims was generated under the folder P001. So instead of producing a single AI response, the pipelines generated a set of versioned legal work products. Invention analysis report version number 1, compliance review report V1, feedback file V1. Let's first look at the invention analysis report. This is not simply an AI response inside a chat window. It is an explicit versioned legal work product that can be reviewed, revised, and reused in later stages of the workflow. For example, here the report identifies the inventive concepts, technical features classification, distinguishing features, supporting features, dependent claim features, and the report also shows patentability assessments. And finally, it provides a ranking of distinguishing features. Let's turn to the compliance review report. Here, instead of asking the same AI model to double-check itself, I assign this responsibility to the compliance review agent. The compliance reviewer evaluates whether each required steps of the invention analysis workflow has been completed. The review itself also becomes a versioned work product within the production pipeline. At this point, the attorney enters the loop. Let's look at the feedback file. Instead of leaving comments in a chat conversation, the attorney records structured feedback in a dedicated feedback file. Now, to keep the demo simple, I will provide a short piece of attorney feedback. Basically, we just disapprove everything. Are the inventive concepts properly identified? We just say no. And we'll leave some comments. For example, we can see the 3 inventive concepts are reasonable. However, invention concept 1 and 3 appear closely related. And accordingly, we just say, no, we don't want to approve the technical features. And we also leave some comments. Similarly, we just say no to everything. It accordingly. Okay, let's double check. Okay, and now I will ask the pipeline manager to execute the revision pipeline. Tag the manager. Hello. Okay, the pipeline is ready. Basically, I say here, same project P001, and please revise based on version 1, and I include the feedback file here, and send. Okay, and the manager is executing the revision pipeline right now. Let's wait. Okay, the pipeline has completed its revision execution. Here's the response from the pipeline manager in the chat box. As before, the pipeline generated another set of version legal products, as you could see here. We have invention analysis report version 2, compliance review report version 2, and feedback file version 2. Let's compare the revised invention analysis report with the previous version, version 1. I will put them side by side. As you could see, in the first version, version 1, we have inventive concepts 1, 2, and 3. And right now, inventive concept has IC1, IC2, but no IC3. So inventive concept 3 was migrated into inventive concept 1. Let's scroll down. We also notice that some of the technical features are broadened. And accordingly, some assessment here for distinguishing features, supporting features, dependent claim features are updated accordingly. That concludes the demo. This demo illustrates the central idea behind the system. Rather than producing a single AI-generated response, the pipeline coordinates multiple specialized AI agents. From building this prototype, I came away with 4 design principles. First, task and workflow decomposition. Complex legal work should be broken into specialized responsibilities, with each AI agent focused on a single task. Second, versioned work products. Every stage should produce a reviewable work product that become the inputs to the next stage. Third, deterministic execution. Workflow orchestration belongs to deterministic software. Large language models should provide reasoning, not process control. Finally, quality and human oversight. Review and revision remains essential, and attorney stays in control throughout the production pipeline. Although this case study focused on pattern invention analysis, the architecture itself is much more general. The same principles can be applied to many legal workflows. For example, for patent drafting, each stage, from invention analysis to claim drafting to specification drafting, can become part of a specialized production pipeline. In discovery, different agents can perform document classification, privilege review, issue spotting, and evidence summarization. For motion drafting, the pipeline can coordinate legal research, case law analysis, argument development, drafting, and quality review. So you can see, even though the individual legal workflows are different, the underlying architecture remains the same. That is why I view this not just simply as an AI assistant, but as a reusable framework for AI-native legal production. Thank you very much for watching. I hope this presentation offered one perspective on how we might build AI systems that legal professionals can actually trust. If you have questions, suggestions, or ideas, I would love to hear from you. Thank you again, and have a nice day.